Hello, everyone. Welcome. We're just going to take a minute or two for everyone to log on. Glad to have you here today. Simone, if you want, you can start our slide. Good morning, everyone, or afternoon for those of you on the East Coast. Thanks for joining us. We're just going to give one more minute for people to log on. The numbers are still going up right now. Hello, welcome. Welcome to you all to this webinar on new approaches for integrating remote sensing tools and other technologies into compensatory mitigation programs. We're really happy to have you here. Welcome. I think our participant numbers are slowing down, so we'll go ahead and get started. I just want to welcome you to this webinar. We're really happy to have you today. We have a really great afternoon or morning, if you're on the West Coast like me, of discussions and presentations, and we're really looking forward to it. So thanks for joining us. My name is Rebecca Kisslinger. I'm the Senior Science and Policy Analyst at the Environmental Law Institute. I direct our wetlands program, and I help to lead our community resilience work. With me today is Simone Baldwin, who you may have already heard from. She's the lead of our technology and innovations programs. For those of you not familiar, you can go ahead 2 slides, Simone. For those of you not familiar with ELI, we're a nonprofit law and policy research and education organization. We're based in Washington, D.C. We've been around more than 50 years, coming in on 55 years, I think. Our wetlands program provides timely, balanced information on wetland law, policy, science, and management through research and publications, through education programs like our National Wetlands Awards program. And if you're not familiar with that, please contact me and I'd love to tell you more. And through convenings like this workshop webinar today. This project, looking at remote sensing and wetland programs, was funded by an EPA Wetland Program Development Grant. We thank them for their support. And these were also developed with input from a fabulous advisory committee of experts, and we thank you for your input. Okay, we can move on. So today, this workshop's goal is to look at how remote sensing and other technologies can be applied to compensatory mitigation projects and programs. This webinar is part of an ongoing initiative that we've hosted to discuss new technology and wetland programs, including protection, restoration, and management plans, programs, and policies. The first of these webinars that we hosted was on new technology, wetlands, and participatory science. So we had a discussion around community science with community groups and watershed groups. The second of these webinars was more focused on wetland resilience, how new technologies can help inform those programs and projects. Both of those webinars are available on our website. We'll drop links to those webinars in the Q&A so that you have access to them if you weren't able to join. And we wanted to really be have a conversation specifically about compensatory mitigation and how these new technologies are already being applied in this context and how they can be. Our goal was to bring together you all, practitioners, researchers, policymakers, decision makers, in the compensatory mitigation field to discuss opportunities for integration of technology in the program. We're going to discuss and review emerging technologies, and we have including things like drones, camera, LiDAR, satellite, AI, things that you're hearing about or may already be applying. We're going to talk about some examples of using these new technologies in mitigation projects and highlight opportunities and actually the challenges as well of using these remote sensing and other technologies in the program. We have a really packed agenda for today. A great number of speakers who are going to provide really interesting insight into what's already happening and some opportunities and challenges to look forward to. We're going to start with a kind of broad overview of technologies. We're going to move into some examples from some companies developing these technologies that are being used in a broad array of contexts, including compensatory mitigation. We'll take a break, and then after the break, we're going to talk more about people who are applying these tools in the compensatory mitigation context already. We're going to hear from the Corps on things they're developing, as well as in the feed program, a mitigation banking firm, and a land trust working on long-term management. We're going to finish with the remaining time and a little discussion, and we have some discussion prompts to talk about. And we'll get into that agenda a little bit more, and I'll introduce the speakers as we go on. I will mention that on our event page, and maybe Simone, we can also drop the link to the event page in the Q&A. We do have the bios for all of our speakers there. So in interest of time, I'm not going to go through each bio, but you'll be able to find the bios on the event page for this webinar. If there's anything, okay, I think we can move on. Before we get started, I just wanted to go through a few logistics. Because we have a good number of people on the webinar today, we're going to just use the Q&A function for questions, and I'll moderate those. So please, we want to hear from you. We want to try to answer your questions. We want, to build some discussion. So please drop those questions in the Q&A. I did see one already about whether or not this webinar was going to be recorded and made available. And yes, it will be. We will post the recording to the event page on ELI's website. So you'll be able to find it there. And at that site that Simone's going to drop in the Q&A. If you have any technical difficulties, questions, drop those as well in the Q&A, or you can email Simone at baldwin@eli.org and let us know. We want to make sure that everyone has good access today. So please go ahead and do that. We do, as I mentioned, have a planned discussion at the end if we have some time. So hopefully we will. We are going to use the Zoom poll function for some of that. And speaking of the Zoom poll, we're going to start with that. We're going to try to get you warmed up on participation. And we really want to know who's here today, who the audience is. It helps us know how we can better provide you with resources, as well as the speakers know who's there. So I'm going to launch a poll and just ask a few questions about who's here and how familiar you are with some of these new technologies. So I'm going to launch the first poll. There's 3 questions in the first poll. The first on what program or organization are you involved with? Would you describe your position? And then what region you're joining us from. So if you can go ahead and answer the poll, give you a few seconds, and then we'll let you all know who's joining us. Numbers are climbing up. We'll give you a few more seconds. Going down. 5 more seconds, and then I'm going to close. Okay, 80% is pretty good. So we have, and for what program or organization are you involved with? We have other government agencies not on the IRTs as our biggest component. We also have IRT members, mitigation banks, some in lieu fee programs, academia, and NGOs. How would you describe your position? Scientist, manager, policy, academic, lots of scientists, great to see. Managers, other. What region are you from? A really good distribution. So Pacific Northwest, East, Southeast, some folks from the Gulf Coast and Midwest, and a few joining us from outside the country. That's great. Thank you. Oh, maybe I didn't show you. Here are the results. Can you see those, Simone? Okay.
Becky, I'm getting some notifications that there's some feedback for your audio. Is anybody still picking that up? That could put that in the Q&A just to make sure it's cleared up.
Okay, let me know. I'm almost done talking, so. Okay. And now I'm gonna go to the next poll. Oh, wait, let me see. I'm gonna stop sharing that. Okay, and we want to know how familiar you are with remote sensing techniques. So there's 4 questions here. Where are you getting your data? How are you using it in your everyday work? And here we're using remote sensing as sort of a catch-all. So there's lots of technologies, remote or not, that could be under that umbrella. And how are we doing on the feedback, Simone? Is it okay?
I don't see any additional comments, but yeah, again, folks, if you have
Please
any,
let us know.
Yeah, please let us know in the Q&A. But don't see additional comments about it, so
Okay.
we'll keep looking into it.
Thank you. Give you a few more seconds. Getting near 50% participation. So 20 more seconds. Awesome. Okay, I'm going to go ahead and end the poll. Share the results. So hopefully you can see that. So how familiar are you with these technologies? A good chunk of you said understand the science and it informs your work. Others said I'm using it every day at work. And then there's a good distribution of new to the field. So that's great. Oh, did we keep the long answers in, Simone, for the last ones? Okay. Do you want to show that or should we move on? Oh,
Yeah, I can share those out. Okay. Hold on, give me one moment here.
so we'll share so you can take a look at some of those long answers. Thank you for responding to those polls. It looks like lots of satellite drones, LiDAR, open source. Great. Let's move on to the next question, Simone. LiDAR seems to be satellites. Great. And then where do you get most of your data? So open source, contract out. Let's scroll down a little. This is really helpful. So thank you for doing this. And we can, when we send out the thank you for this webinar, we'll send out the results of the poll so you can all see what the range of was on the webinar. So thank you for doing that. We really appreciate it. So I'm going to move on now to our first speaker. And we're going to have some time for an introduction, kind of a broad overview of remote sensing and technologies from Dr. Mac McKee. He's the former director of the Utah Water Research Laboratory. He's joining us from Greece. So thank you for being available today. We're really looking forward to hearing from you. And again, bios are on our event page, so you can look more into Dr. McKee's work. So thank you again, and I'll turn it over to you.
Thank you. I'm happy to be here. I'm arranging the various chunk that pops up that Zoom does to you when you share your screen. I'm a professor emeritus from Utah State University, retired a few years ago. I'm a civil engineer by background, and I was told to give an introduction to remote sensing, which in 15 minutes is a tall order, and so you're going to get what I give you. What I plan on giving you is a short definition of remote sensing. I'm assuming that there are some folks in the group here who are not very familiar with the topic. I'll share some very, very basic principles of remote sensing, things that we had to learn the hard way. I'll give you an example, a couple of examples of some things we've done in monitoring wetlands and other things from a group that we created called Aggie Air. This is in Utah Water Research Laboratory. We began this thing in 2006, March, as a matter of fact. So we've been doing this for a long time. My focus is mostly going to be the use of drones. I will mention satellites in passing. I'll wrap up with a view of what I see as challenges, a short list, a very short list, to remote sensing, especially drone-based remote sensing, and then move on to some questions, which I hope we have plenty of time for. What is it? Remote sensing is simply the ability to acquire data about some object of interest without actually manipulating that object. It is more complicated than that, but that's a good start. You can look, but don't touch. The data you get consists of your imagery and numeric information in it. That must be transformed into useful information that answers questions that you might have. This transformation of data into information is a multi-step process and almost always interdisciplinary. In the imagery in the upper part of the slide here, we were called in to make some flights over a small stream in northern Utah called Curtis Creek, where a colleague was doing some work in energy balance of surface and groundwater and things. And a rogue group of nasty beavers moved in and built beaver dams and messed everything up. So we were getting some thermal imagery for them. So there were all kinds of disciplines involved in that. The information that you want should drive everything else. The information you need should dictate what data you collect. That should determine what sensors you select and what platforms fly them, the flight plans, and lots of other stuff once you get into the field. There are trade-offs between satellite and drone-based remote sensing. We do a lot of stuff with satellites as well. The science and the physics are the same in terms of remote sensing, but the trade-offs in terms of spatial and temporal resolution, the amount of geographic coverage you can get, the processing, computer processing you must do, the flexibility of the sensors. Can you obtain the spectral bands that you need? All of these things have trade-offs in them. In the lower right, there are trade-offs among UAV platforms, drone platforms, in terms of cost and difficulty and coverage. I would imagine most of you who are flying drones use vertical takeoff and landing VTOLs. We do too on the right there. We have a long history of flying our own homegrown fixed wing aircraft. And the cost and difficulty level and so forth are very different from VTOLs. And now, for the last few years, we've been flying hybrids. It is a VTOL and takeoff and landing, but otherwise flies as a fixed wing. We can cover very large areas And it's actually easier to fly than a fixed wing. And the reasons for that I can go into if there are questions. In terms of basic principles, it goes like this. Each image you collect in a remote sensing flight will have millions of pixels, tens of millions of pixels. You might wind up with hundreds or thousands of images per flight, depending upon what sort of sensors you're having. Each pixel contains a digital number. This is just an integer number that is representative of the amount of light energy reflected from some corresponding point on the Earth surface. This is important because not all cameras are created equal. The little graphic there, if you look at the three curves in sort of bluish color on the right, that is supposed to represent near infrared for three different cameras. And as you can see, the curves are not the same. That means you're going to get different solutions if you use the near infrared band in whatever analyses you do. You have to know about this. The quality of the data is a function of spectral fidelity. I'll go into what this means. Spectral fidelity, something that you'll recognize in terms of positional accuracy, spatial resolution, and you might or might not have heard of radiometric correction. Super basic principles, spectral fidelity. We work with all kinds of projects where certain spectral bands are required from the cameras we use in order to produce the information that our clients want. That's illustrated in that first multicolored panel there, where the electromagnetic spectrum is on the x-axis. Transforming these data pixel by pixel into information requires that the pixels be acquired in ways that meet certain scientific standards, in addition to matching the spectral bands that you want. You have to worry about Lambertian calibration, just making sure that the reflections you're recording are of high quality. This is used for camera corrections for camera vignetting and operating the camera, exposure and gain, and so forth. So you have to be careful in selecting your sensors, and you've got to follow the field protocols through all of this. More basic principles, position accuracy. The overlapping images collected in a single flight, and this is the same whether you're talking about satellites or drones or whatever, must be stitched into a composite image or a mosaic. This requires considerable ground control where points on the ground are very precisely geolocated. We do that usually in the upper images on the right there with survey grade GPS. And we lay out usually a very significant number of ground control points that are visible in the imagery. There are about 20 of them shown in that lower photo over a vineyard in Sonoma County, where we've flown several times. The positional error in the mosaic pixels needs to be minimized, especially if you're going to acquire imagery at one point in time and again at another and compare those two. If you can't place one on top of the other geographically, then your data quality is not so good. Spatial resolution. The cameras you're flying and the elevations you're flying them at will dictate the spatial resolution you have in your imagery. It can be very grainy, as illustrated in the upper half of the photo or the image at the right. Or if you've got the right kind of cameras and or are flying lower, then you get something like the lower half of that image, which is from one of our Aggie Air applications over Fish Lake in south central Utah. Now you can improve the resolution by just getting a camera with more megapixels, but this does not necessarily mean you're going to get more or better data. And you might be much worse off if you do that. And this is due in large part to diffraction, also a number of other things, but to the process of diffraction and something called the point spread function. I can answer questions on that if you have any. Once you have your imagery and it's not necessarily ready to go yet. Very often, especially satellites, but even some of the stuff that we do close to the ground requires that corrections be made in these digital numbers in your imagery to account for atmospheric effects and so on. What you want is a good estimate of the energy reflected from the surface, and the atmosphere and other things get in your way. So that correction has to be made. Then you need in your imagery, pixel by pixel, the precision that is required to answer the questions you're trying to resolve. This is obtained by in the form of the digital number that represents the reflected energy, light energy, in each pixel, and that can be a coarse representation or a much finer representation depending upon something called the bit depth. Each pixel has an integer number represented as a sum of powers of 2, and these usually come in 8-bit or 12-bit or 14-bit or 16-bit varieties. An 8-bit number will give you 256 different possible values for reflectance. If you need finer resolution than that, then you have to select a greater bit depth. If your camera is not bit depth flexible, you might want to look for a different camera. Greater bit depth, as I said, gives you greater resolution in the reflectance that's measured. And this might have implications for the quality of the answer you get. Note that as you increase the bit depth, the size of the files that contain those images also increase. Going from 8-bit to 16, I believe, doubles the size of the files. Once you get your imagery, you might have hundreds or thousands, or in our case, often tens of thousands of images that have to be stitched together in a mosaic. The software to do this is now commercially available. It's a lot cheaper now than it was 18 years ago. We paid almost $20,000 for our first piece of software that did this. These are all based on mostly on classical photogrammetry principles, maybe some pattern recognition, and then lots and lots of trigonometry and optimization. And so they're resource intensive when it comes to your computer, but they've gotten good enough and easy enough to use that you can do it. But you have to be careful. We've had any number of cases where the result that came out of the software, the stitching software, was really not very good when you got your microscope out and took a good hard look at it. The big thing we're struggling with right now is that it just does not scale well geographically. For 50 or 100 acres or something or hectares or something along those lines, it's probably just fine most of the time. But we fly thousands or tens of thousands of hectares in some of our applications, and it is a real stretch to get it to work there. In terms of examples, real quickly, one of our earliest applications in monitoring was Phragmites australis, this invasive reed species that is taking over wetlands all over the world. And this application is on the north side of the Great Salt Lake. There's an image on the left of Phragmites. It can get really big. The center image there is a composite image in visual spectrum, red, green, blue. The one to its right is a false grayscale near infrared. Those images were used to, in a classification algorithm, homegrown algorithm we built, but based on a relevance vector learning machine, to classify what was in the imagery. Different colors in that upper right imagery mean different things. Thing of interest is the bright red. That's Phragmites australis at 95% accuracy. And if you fly in June and July and August, September, you get a classification for each of those flights. You can overlay September on top of June and look for differences. That's change detection, as illustrated in the lower right. The different colors mean different things. Thing of interest is bright green. That's where there was no Phragmites in June, but there is in September. So you can get an idea of the rate at which you're losing the fight against the stuff, and maybe some idea of what works and what doesn't in combating the stuff. We're also successful in measuring the growth of individual patches of Phragmites very, very accurately. And this, we had all kinds of biologists and geneticists and everything working on this. Some of these patches were doubling in about a year's time. One final example, this is Fish Lake in south central Utah. If you were flying in September of 2016 at 650 meters over Fish Lake, the image at the left is what you would see. If we could screw in some optical filters into your eyeballs and add coastal blue to what you can see, then you can see what's beneath the water surface with much more clarity. So that's the center panel is a composite image of 4 spectral bands, RGB and coastal blue. That was used to classify the vegetation and other items in the lake below the water surface. The bright red on the right panel is Phragmites, or is milfoil. Probably been saying Phragmites, is milfoil, the species, the invasive species we're worried about. The yellow is milfoil floating around on top of the lake. In terms of challenges, for the past 18 years, we have worked mightily to try to drag FAA out of the 12th century and into the 21st. FAA regulations have significantly retarded the development, the commercial development of drones and sensors, and have made all of us pay higher costs for doing what we do. And this isn't going to get better very quickly. It will improve, but it's doing so at glacial velocities. Second thing that some of you might not know about, this was brought to our attention just about a year ago, a little over a year ago. Certain federal agencies are adopting policies now that ban the use of Chinese technology and for drones, for platforms, as well as sensors. This is for economic and national security reasons. Started in the Department of Defense, it's spreading to the Department of Interior, Agriculture, and others. And you might need to check into that at some point. We have gone now out of our way to remove ourselves from Chinese technology. Something we've fought all along is just the lack of funding for ongoing monitoring. Maybe you live in a place where deep pockets are all over, but in Utah they aren't. And we can always find money to go out and take a look at milfoil or whatever endangered species or whatever invasive species. But if you want to come back and do it again next year or 2 years from now or 5 years from now, the funding for that is going to be very difficult to obtain, or very often at any rate. And with that, I'll wrap it up. This is again from Fish Lake with 4 spectral bands. I call this image the color of data. Are there any questions? I'll leave you with this while we're covering questions. It's just a short list of some of the monitoring applications that we've done at Aggie Air over the last 18 years.
Great. Thank you so much, Mac. That was great and perfect timing. So that was perfect. Please put some questions in the Q&A if you have them. I have a few, so I'm going to kick it off while we're waiting for others. I was wondering if you have any thoughts on best practices that you've learned over the years, because one of the things you talked about on the software slide was you said buyer beware. And you talked about making sure you have some QA QC and in that process to make sure you're getting what you think you're getting. So, which I think is a good best practice. Are there other things that you have developed over the years that, through the whole process that you make sure happen for every project?
Well, relative to the stitching software, those are the main points. Every time you use it, make sure that it did what you expected it to do. Ask some tough questions to those guys. There are some competing alternatives out there. You can spend a lot of time evaluating them, and we have. There are 2 or 3 that are pretty high in the market. I would recommend you check out all of them and do so periodically. We have a full-time person at the Water Lab whose job is to stitch imagery and stay on top of what the heck's going on commercially. I would also ask lots of really tough questions to anyone who wants to sell me a camera. And if you don't know what questions to ask, I'm happy to help out. And please give them my email address. I'm happy to point directions if anyone has questions. Similarly, if you're hiring services, if all you want is the imagery, be very specific in what spectral bands you want them to produce for you, and understand things like bit depth and the quality of the imagery. If they cannot give you, or if the camera provider, if you're buying a camera, if they cannot give you a graphic that shows you the spectral response of each of the bands in the camera, then I would go shopping somewhere else. So those are the things that first come off the top of my mind. One other minor, it's not minor, it's very important, but I'll do it quickly. We have found that post-flight analyses of some of the products has been really, really valuable to us. We built our own post-flight analytics that refine the information in the imagery from a spectral perspective, so that when we fly, we match the best satellite data that NASA produces in terms of Landsat, for example. Similarly, field protocols. We have a long list of field protocols that are followed rigorously, biblically, for each and every flight.
That's great. That's really helpful. And we had a few other questions along those lines. So hopefully that answered some of your questions. But Simone put your email address in the chat, so feel free to follow up. We do have a few more minutes, and I wanted to ask, somebody asked about explaining the unknown methods that are used by AI. Learning to classify features. How do you address those? Or
classification algorithms are commercially available, and there are some that Google it and you'll find software that runs with some of the Esri stuff and everything else, and these are typically relatively easy to use with GIS systems. They typically kind of max out at, if you can get 75% accuracy, you're doing okay. Our homegrown character, which we've used for a number of different classification problems, used a relevance vector machine to perform the classification. If you look at under Google, under learning machines, one that will pop up, there'll be neural nets and support vector machines, relevance vector machines, and deep neural nets and all kinds of stuff. One that will pop up is relevance vector machines. They are very good, relatively easy to use, although it takes some effort. I won't lie to you. But if you have enough data, they for the right kinds of problems, they'll nail it dead, and it did this one. So, and again, if you have specific questions, I'm happy to answer anyone by email.
Great. We're running up against time, but I did want to get to this one, and there are some more specific questions in the Q&A, Dr. McKee, if you want to take a look. But Lauren asked if the lack of ongoing funding for monitoring a plus or minus for using remote sensing. Getting money for monitoring is a big issue for on-ground work, but that makes remote sensing approaches look more attractive. Does that seem right? Like, what's the...
Well, it's been our experiences. It's been relatively easier to get money funding for a first cut at understanding where the problem is and how big it is and what's involved and so forth. And if you can do that, it's worth doing it. But if you're going to invest in management activities that are intended to address problems like mitigation or any of a number of other things, resources management problems, you're not going to know how well your investment in management is doing unless you go out and look at it once in a while. And if you have to look annually or once every 5 years or whatever, then maybe you don't do it with remote sensing if there will be no money to do it that way. However, once you can do it, you know how to do it, and the repetition we found got easier and easier. So also much depends upon the scale. We were doing this over thousands of acres, and that's a lot tougher than if you're just monitoring 100 acres.
Yeah, thank you. That's a good point. Thank you again, Dr. McKee, for that presentation. It was really great. There are some more questions, and we'll hopefully get to those later or afterwards. But again, Dr. McKee's email is in the chat. We are going to move on to our next set of presentations on some examples of remote sensing technologies. Our first presentation will be from Andrew Minderman, a geospatial operations manager at SkyTech LLC. And that will be followed by a presentation from Clay Ward in Growth and Partnerships at Upstream Tech. They're going to tell us about their tech and how it's being applied and in the compensatory mitigation field as well. So thank you. I'm going to turn it to you, Andrew.
Yeah, thank you.
Looks great.
Yes, my name is Andrew Minderman, Geospatial Operations Manager at SkyTech, and talking about examples of remote sensing technologies. SkyTech, we're a small company established in 2015, based out of Chattanooga, Tennessee, with over 50 years of GIS expertise. So we are made up of environmental science backgrounds. Our pilots are well trained in the field. We're all, very familiar with the field work and also the imagery analysis, and staying on the cutting edge of the industry as well. Services that we provide, we have a remote monitoring service called the Ranger that I'll talk about in a little bit. We do geospatial consulting, and we started out with drone mapping and analysis, focusing on photogrammetry and then implementing LiDAR. So we've definitely gone a long way since the beginning. We work very closely with Esri. We're in their partner network, the silver level. We do provide GIS consulting, drone mapping, and Ranger in the ArcGIS marketplace. We have the nonprofit specialty and the ArcGIS System Ready specialty. We also partner with Planet for imagery and Pictera for our GeoAI and analytics. So today, this kind of serves as the overall agenda and outline of the presentation, but the main key technology advancements of remote sensing and remote monitoring that we're seeing that really have played a huge role in allowing us to monitor what matters and be able to fill in areas where funding may be difficult, or you're needing consistent imagery sources. There are more and more options than ever. So one is multi-scale sources. The other is high frequency acquisition, geo AI analytics, and then platforms and marketplaces. And again, many of these have existed for a while, but now more than ever, there's so many options. Barrier to entry is much lower, or the pricing is much more palatable. And so being able to tie these together makes for a really powerful platform. So starting out with multi-scale sources, this graphic, we've used this for forever. It does a fantastic job of just showing, multi-scale remote monitoring, remote sensing. It's from SenseFly. So it allows you to just get the resolution that you need, whether it's in the field or UAS or airborne satellite. It could be just one, or combining a couple of them, or using a full portfolio. But it's important to us to have a very good understanding and experience at all levels, and be able to offer those to clients. So starting from the ground, field monitoring is very important with verification, validation, and just having whether it's the baseline or the authoritative control point. It's extremely important to be able to have a very clear understanding of what is going on the property, and that is the absolute option. So we're very familiar with ground control points. Work with professional land surveyors. We incorporate oblique imagery that's captured on site. You can measure on oblique imagery and look at it on 2D maps. You can submit surveys using Esri Survey 123, including images for status updates. We can incorporate IoT, so different sensors that are out in the field, and also traditional field monitoring. So moving up, looking at UAS and airborne. With UAS and airborne, we have such high density LiDAR point clouds and high resolution imagery. But going back to Dr. McKee, high resolution may not solve the problem. It really comes down to being able to understand how the post-processing is done. And we've been able to achieve survey grade topos, and working directly with the surveyors to ensure that our data is being handed off to engineers with confidence. And having this level of detail just create a very authoritative baseline. And it's a great option for future protocol for long-term monitoring programs. This is a profile view of LiDAR that we collected using our drone. And as you can tell, it is very rugged terrain. It's fully classified, so each different color represents a different classification. And it would be very difficult to walk that doing a traditional survey. And in some cases, it could be too tight of a corridor for getting the point density that's needed for the the power lines. If airborne imagery and LiDAR, if they're flying high up. So this is always a fascinating view to see. This is kind of a tri view. The bottom is a profile view where it shows the orange ground points and the very dense vegetation above it. And then the two panels on the top left and top right are filtered to the ground points only. So you can see the stream profile in the top right, and the white box shows what's being shown at the bottom profile view. And the bottom profile view, the orange points, it really goes to show how important and how valuable LiDAR is, because it's I'm in the southeast and we have so many forested wetlands, and it is very difficult to see what's actually going on and understand the geography without having a firm understanding of the elevation. And so this is why I like to include this slide, because looking at the image in the middle, it looks, leaf off conditions, fairly straightforward. When you look to the panels to the left and to the right, you can see that there's quite a bit going on that's not being revealed by imagery alone, and really great stream profiles, and we're able to verify accuracy with the ground control points that are collected in the area. So it's a valuable tool to have, and we've been using it more and more, and seeing the 3D environments, getting really excited each time the point cloud is being generated. It really does serve as a digital twin for baseline conditions. So having 3D design grade digital models of not only the built environment, but the natural environment. So digital twins are getting huge recognition in the built environment, but I think there's a very good future for capturing these extremely precious areas in the natural environment as well. And it's perfect for mitigation projects, being able to show pre and post design. Satellite imagery is a fantastic option in multi-scale, with frequency being daily, multiple times a day at this point. With change happening so quickly, it's imperative that we have the capability to capture that change and verify and be able to show before and after. And with higher frequency, it just makes for a much stronger solution for Earth observation. It can be expensive, but there can also be cost savings. So what we try to do as a company is, find the best fit, whether it's a certain frequency or resolution or combination of different satellites or sensors. So not just UAS or aircraft or satellite, finding kind of a prescriptive or kind of a recipe-based solution. And with satellite imagery, you can cover a lot more area and have quite a bit more bands. So being able to pick through that wavelength is huge. And again, this is an image from Planet showing their constellations, and just completely covering the globe multiple times a day. High resolution satellite tasking. This is available. You can do this like you would getting an Uber essentially at this point. And one feature that we really enjoy is being able to task a satellite, or a client can task a satellite, and have high resolution imagery delivered within 24 hours. And then we can create a mobile map tile package, and they're able to take that imagery offline into the field within that 24-hour time. So it's extremely powerful. Geo AI analytics, this goes hand in hand with the multi-scale remote monitoring and remote sensing. So this is an example of image differencing, spectral differencing, taking NDVI from one time period and comparing it to an NDVI at a later period. And green areas show vegetation growth, magenta show harvesting or disturbance. And it really has the ability to make the change, stand out very clearly. And this shows two images, RGB on the left-hand side and the image differencing on the right. And we're able to actually extract the change that's going on and display it over a change detection raster, and still be able to trace the pixels within the changed area back to the source image. So the last one is platforms and marketplaces. It's becoming a very saturated market, saturated industry. There are more and more sensors popping up every day. A lot of platforms, analytics, it can be very difficult to navigate. And that is one thing that we like to do is help navigate the very complex market and saturated market. So it challenges and limitations, cost restrictions. You can't, it's not feasible to have SkySat every single day, but it is very valuable to have a SkySat capture at certain intervals during monitoring. So acquiring data, a lot of times it can be unclear. Subscription models can be a bit hard to understand at times, or not fitting the budget, which goes into a best fit option. Sometimes it's you can't just get a one-off and be able to solve the problem that you're working towards. And with the very competitive market, it can often be misleading. So seeing features being advertised as 3D when it's actually 2.5D. It's not a true three-dimensional data set. It's essentially just draping data over a resampled terrain. It does go back to what Dr. McKee was saying of really asking the right questions, knowing what to look out for, and we certainly are here to provide answers and provide the questions to ask. And traceability, with more and more sensors hitting the market, there's a large push to have fusion data, analysis ready data, and it's a good thing because it allows for gaps to be filled in image stacks, but it is something we have to really watch out for because it does have a high level of interpretation between sensors with different resolution, different spectral responses, and fitting the spectral responses to basically fit together. And it does make it very, very difficult to trace pixels back to the image level. And if images are being reprocessed, it can be very difficult to catch that in an image stack. So ultimately, the problem is that there's an increasing rate of change. It's happening everywhere, and we have to not only keep an eye on it, but monitor it and capture before, and if the after is not good, we need to correct it, and speed up the ability to response, and make sure that technology is easily accessed and affordable. And our solution is Ranger, an Earth observation platform that allows near real-time monitoring at a global scale for natural and built environments, so you can monitor what matters. And so that it basically takes the multi-scale sources, high-frequency acquisition, analytics, and sorts through platforms and marketplaces. And then it really ties all of that together just to provide a solution. So this is a screenshot of Ranger. I did include a link to a story map that goes much more in depth with it. We are built on top of the Esri platform and integrate directly into ArcGIS Online and can scale to enterprise portal. And on the right-hand side, you can see You get direct access to the Living Atlas, so you can easily pull in, with no added cost, easily pull in data from Sentinel-2, plane cover, which is provided by Impact Observatory, many imagery sources, different data types that many other competitors or marketplaces or platforms are, charging extra, serving as add-ons. So it's a really powerful tool. And I always like to share this. I added this in this morning, but again, another layer you can add in live stream gauges. There's a warning at the moment, basically saying that there's a high level of usage. It's trending. So it's interesting to see, remote data being showcased in this manner. And this is a very quick example of change at multiple scales. So planet scope before, and then a planet scope after, where a pond was being made at a residential area, and then the organization tasked SkySat, so it became much more clear what was going on, and then ultimately got an even closer look with UAS. And so it's a great example of having a multi-scale approach and being able to drill down when change is detected. And yeah, the link to the story map, I can share that, and that'll also be on the slides at the end.
Great. Thank you so much, Andrew. That was really great. Thank you for walking us through that technology. I'm gonna turn it to Clay to give his presentation. I really appreciate it. But I did have one question for you, Andrew, before you go. We had a question on the analytics side, and that it shows vegetation growth, not just loss and land disturbance. What is the size of vegetation growth that can be measured? They're interested in being able to measure growth gains in riparian restoration and plantings.
Yeah, that's a great question. It really depends on the imagery that's being used with the spectral differencing. So that was done with PlanetScope, which is 3.7 meter. So it can be a bit coarse. PlanetScope is a fantastic product, but it has proven to be quite challenging for species detection. So really it can be at the resolution of the two images that you're comparing. Ultimately, you want to make sure to keep the two resolutions identical.
Great, and we'll have time for more questions, I think, after Clay, but in the meantime, I'm going to turn it over to Clay.
Awesome. Thank you.
You.
I think
Looks
everyone's
great.
on my slides now. Thanks to Environmental Law Institute for putting on a great program. I've been looking forward to this. My name's Clay Word. I work for Upstream Tech on our Lens team. And just for the next 15 minutes or so, I have a number of slides to run through to chat through our remote monitoring platform Lens and how I've seen a number of our partners leverage Lens for their mitigation and restoration projects. And then since Lens is a online platform, I figured I'd just hop into Lens, show y'all a quick couple examples. Figured, if a picture's worth 1,000 words, a demo's got to be worth a few more than that. And like Rebecca said, I think we have some time for both Andrew and I to answer questions at the end of this presentation. So without further ado, I'll hop into it. And Upstream Tech. So we're a technology company. We make a couple different software products specifically for natural resource folks. I think we're really fortunate to live in a time where information and data is seemingly endless, but getting that information to a usable format and something that we can easily digest and then push out to our projects that we're putting into the ground can be challenging. And so that's really what our products seek to do and provide to natural resource professionals. So if we're doing our job right, that means that the results on the ground will be better for y'all, and we're going to impact the scale of the conservation and natural resource work that we're doing. And so Lens is our remote monitoring tool for natural resources. And I think of Lens as making remote data accessible in a couple of different ways. I really liked that infographic that Andrew just showed that had like the different temporal and spatial frequencies of collecting data on the ground, then like a drone, and then maybe a plane, and then a satellite. So Lens kind of serves those satellite and aerial data sources. And so what we're doing is we're aggregating a wide variety of data, both publicly available and commercial data, into a platform that's really intuitive and easy to use, so that basically anyone, regardless of their geospatial experience, can make observations and detect change for the projects that they are implementing on the ground. And I don't think any of us ever want to eliminate field work. It's important for our industry. It's always great to put boots on the ground. Personally, why I got involved in natural resources, because I wanted to spend time in the woods. But if I can inform my next field visit, or eliminate one of the many field visits that I have to take to a certain site, then I'm going to save myself time. I'm going to spend less time in the car behind the windshield. And then, that adds up in terms of personnel and cost savings, which can be really important. So that's really one of our goals with Lens, is creating that efficiency for workflows within natural resources. And with Lens, you're able to collaborate really well with your colleagues. So as I'm sorting through Sentinel data or NAPE imagery, or looking through a commercial high resolution image, or looking at NDVI, forest productivity, and making observations of either a site I'm prospecting, or maybe we've completed construction and it's on its 5-year reporting timeline, or it's a mitigation bank and it's been sunset and it's in its long-term stewardship, I can create notes and my colleagues can see those. We can collaborate together. And then as I take notes, I can streamline those into a really easy reporting format. I know how important reporting is in this industry. And so that can be PDF'd really, really quickly, saved, shared internally or externally with the appropriate stakeholders. We're lucky to work with over 250 organizations across the world, from federal government to state governments to NGOs and consulting firms. I saw Michael from Westervelt in the chat already, and excited to hear Jeanette talk from Montana Freshwater Partners, just to name a couple that y'all might recognize. And I think collectively, we're monitoring something like 170 million acres across the globe with Lens. So really neat to see the scale of the work that our partners are doing. There's a couple different tools within Lens that are really beneficial for helping to pick up, change detection. And everyone loves a good compare mode, and Lens has one. And so you're able to select from any of the data sources that we have, whether it's a publicly available Sentinel image or a USDA NAPE image that's high resolution. You can compare that to NDVI or surface moisture or land use and land cover, to try and detect the nuance of your site and the changes that might have occurred through 2 specific dates. And as you do that, you can create notes and share those with your colleagues or externally with stakeholders directly within Lens. And then the next tool that is really quite easy to use, but can be really powerful, is our Analyze tool. And so this, you can basically draw an analyze area anywhere within one of your properties. This is a forestry area in California, and I noticed a lower NDVI signature, which was pretty indicative of a clear cut, but I wanted to pinpoint exactly when that happened. And so I drew my own area of interest here, and I was able to pull every single Sentinel observation from that since Sentinel was launched. I love Sentinel, and I think every speaker thus far has talked about it a little bit. It captures every 5 days, so it's got this really nice high temporal frequency and captures multiple spectral bands, so you're able to get ecological variables like forest productivity here and pinpoint exactly when that harvest happened, and even select those data points and interact with them. And here I'm saving a note for other colleagues to make observations for. I put together a couple different use cases that I've seen folks use within the restoration mitigation industry. This is not an exhaustive list. It's just meant to get the gears turning to think about how you could use LINS for a mitigation use case. The first is viewing site changes. I know when I worked in the stream and wetland restoration industry and I was prospecting a site or was going to visit a site after construction, I went to go find the earliest possible image of that site and then the latest possible image to say, how is my geomorphology changing? Is the stream moving in this direction? Is it currently eroding? Is my wetland extent changing? How has this forest stand changed over time? And so with LINS, you can select, from a variety of different true color imagery sources and get those and compare them, side by side. Then you're also able to analyze ecosystem data. This data set is surface moisture from the Sentinel constellation. And, whenever you go out to prospect a site or it's finished construction, you're going to have your resource inventory, your state wetlands or your county wetland layer. You're going to have a nice field map or on your iPad, and you're going to be ready to go out and find those and delineate those sources. I really like flipping through this data to identify any potential wet spots that I might want to turn my attention to that otherwise haven't been mapped, or to measure project success. Are we reconnecting the floodplain in the ways that I thought we are? Hey, my project's 3.5 hours from my office. We got a 100-year rainstorm yesterday. The clouds have cleared. Can I pick up anything with satellite data? And a quick flip through LINS could save you the trip there. And I can't tell you how many times I was working on a site and went to go pull parcel data, and the county that I was working in had some archaic system of getting their county tax records and parcel data. Would have to send an actual letter into the county office and with a physical check, and then they sent you a CD or a floppy disk, and it's like a 4 to 6 week turnaround. Well, with Regrid, they're one of our partners, so you can turn on parcel data within LINS. Believe they have up to 99% parcel coverage for the lower 48, and it's going to give you tax parcel ID number, the parcel ownership and its address. And we even have a tax parcel alert. So if the property owner changes, you'll get an alert within your LINS account. So that can be really helpful, both on the prospecting end and like the long-term stewardship to maintain some sort of continuity in case the property ownership changes hands. So I'm gonna try and share my screen real quick and pop over to LINS. So y'all should be seeing what LINS looks like live now. And this is one of my favorite sites, mostly because I worked here back in the day. But we're looking at a thin stream that is a tributary to Gunpowder Falls, just north of Maryland to the Chesapeake Bay. And there's been quite a bit of stream restoration and wetland restoration that have happened around this area. But I'm going to take your attention to this area right here. And I will go back in time to 2005. And what we're going to see is a classic, overly sinuous, probably incised stream that was mowed down to its banks. And in 2007, this area was excluded, and I believe it was enrolled in some sort of cost share program, whether it was CREP or a wetland reserve easement. I don't remember exactly the specifics, but anyways, it was planted and protected in perpetuity. And I'm able to fly through some public imagery here. In the latest NAPE image, I see that there is just this massive hole in an otherwise mature forest. And I want to know what's happening here. And so I'm going to use our analyze tool, and I actually took notes already here. So I'm going to go to my note and open the analysis that I ran for this site. So I was able to trace what we now know as a beaver pond. So we had some beavers move in here. And here's where I'm going to select the variable of interest. So we have different land use, land cover data sets. I mentioned surface water, surface moisture, vegetation, different things there. And I'm going to run this. And this is basically a graph of every sentinel capture in this area back to 2016. And we see this rapid increase in surface moisture, which is indicative of beavers moving in. And I could even run this again. Let's see. real quick. I'll run it again and we can see how change this to vegetation. Say, no surprise, our vegetation, our NDVI has decreased significantly since the beavers have moved in. You know, this was an area that was planted probably in facultative species that weren't quite as water tolerant. And now you have a 150-foot wide beaver pond that is almost perennially saturated. So there's going to be die off of those species until those more obligate wetland species are able to colonize there and take over, which is pretty neat to see that rebound over time. So that's one example. And then another quick one just on this site, I will go back to this latest NAPE image and move up the watershed to this area here, which was also protected, but I knew there was a stream restoration that happened here. And I'd been wanting a high resolution image that I could visualize that new pattern and profile. I didn't have the ability to fly it with a drone when I was constructing it. And Google or whichever imagery provider I typically use hasn't updated theirs. So I can go over to this order pane here, and we have commercial partnerships with Airbus and Maxar, Nearmap, Planet, and anytime one of their high resolution satellites captures an image over your site, it then uploads to this repository, and you can purchase that image for 4 to 6 cents on the acre. So if you ever tried to task an image, it can often be really costly or have high minimum areas. With Lens, you can just purchase one of these images for just your property or even a subset of your property. So if this image here from Airbus was of interest, I could purchase up to 500 acres for about $30, and it would take a few seconds to process. And then that image is yours to keep. You can download it. You can stream that into any of your ARC programs. You can stream it over to AutoCAD as well. And so I was able to purchase an image actually from 2022 and see that nice new pattern and profile that was constructed here. So pretty neat to see, really nice, if you're in the market for high-res imagery as a way to get in at an affordable price and leverage multiple different data sources to kind of weave together a story and efficiently monitor and report on your projects, whether it's on prospecting or on the back end due diligence that's required. So I'll flip back to my presentation and I want to put my email up here. If y'all have questions that don't get answered in the Q&A, like I said, I used to work in the stream and wetland restoration industry. I love chatting about it. I'd be really happy to talk through specific use cases and if Lens is the right tool and software for your work and the challenges that you might be facing. So please feel free to reach out. And with that, I will stop sharing my screen and turn it back over to Rebecca.
Clay and Andrew, thank you for walking through those tools, and I think those are great examples of the tools that might be available to other folks on the call, and I really appreciate that. One question we had come in, and I think you just started to answer it, Clay, but was about how do your platforms integrate these other data sources, which you started to answer, Clay. But things like other open source data, like NASA Earth data, soil inventories, USGS flow data. So do your platforms integrate those kinds of things, or are there plans to do so?
I'll start, and then Andrew, I'll kick it over to you. So we ingest a number of publicly available data sets. I mentioned a couple like Sentinel-2, Landsat, that's from NASA. We have stream inventories as well. Really, there's too many to list, but I can share out a link and you can see all of our available sources through our website that then can be viewed, and you can see if it meets your needs. Yeah.
Great, Andrew.
Yeah, and I slightly mentioned the same case with ours. Using Esri's Living Atlas, it gives you access to a very, very, very large amount of data that's kept up to date all the time. In the story map that I linked at the end of my presentation, it goes into more depth about Living Atlas. So yeah, stream gauges can be directly brought in. Our data can also be used on other platforms using a REST URL. And same case for bringing data in if it's not included in the Living Atlas, where you can't find it on the on ArcGIS online. GeoJSON, map servers, really any REST endpoint, even personal files can be uploaded. So it makes it pretty easy to integrate with different imagery and data providers and different platforms with our data as well.
Great, thank you. And for folks, if you have any other questions, put them in the Q&A. And I also wanted to point you to, on top of the Q&A, there's 3 choices: open, answered, and dismissed. Dr. McKee has been busy answering a lot of the questions. So if you are looking for an answer to some of the previous questions, they're there with lots of information. So check that out. I was wondering, what you all see as like the new things, like what's coming up next? What are you looking towards? What kinds of things might, new and innovative things are coming along that might be useful in this context? Either one of you want to take a
I'll
stab?
be happy to jump in. I mean, SAR can't be ignored by any means. I think terrain in general it's going to be huge. It's going to play a huge role. Stereo pairs, anything that's going to help, give you that true terrain, true 3D model. So kind of like what I was talking about with the digital twins, being able to have that reality capture, whether it's drones, but more so spaceborne, it's going to be huge. And also hyperspectral, when it comes to detecting species, really just, having as many bands as possible. To me, SAR and hyperspectral are huge.
And those are just coming online now, or you're there?
Just seeing more and more of it become available to the general population, and of course higher resolution imagery.
Yeah, I was going to piggyback on Andrew. In addition to SAR, just seeing additional, high res imagery and just data sources coming online, whether it's from public or commercial sources, that as you have more inherently, then competition is great because it drives prices down, hopefully, and makes us even more accessible to the general public. So it's been crazy to see just what we've been able to bring online in the last year and a half since I've been on with Upstream. So I can't imagine what like the next 10 years will look like that's available for folks.
Exciting. A question came in about what you all think about the integration of CAD and survey stations into GIS and remote sensing.
I will kick most of this to Andrew because I'll just full caveat, Upstream and Lens, we don't interact with LiDAR quite yet. It's something that we have in our product line, but it's not quite there. So I know they're collecting a lot of that with what Andrew mentioned. I will say we do a lot of WMTS streaming, which is available in AutoCAD, but specific surveys, I think Andrew can probably speak more to.
I think it's fantastic. I think it's two separate offerings that have so much power when combined. It's been extremely helpful getting a better understanding from the engineering side, from the CAD, what users that are mainly say in CAD software, what are they using the data that we provide? How are they using that data? And it's really anytime we've had a chance to learn more, it's just brought not only our product but our solutions and relationships with the clients, of understanding the problem and continuing to kind of find the diamonds that we can solve. So I think it's fantastic, and it's definitely something that we always strive to strengthen and continue to find ties between. And I mean, there's being able to provide survey grade is huge, and we bring that same mentality to Earth observation. So very, very hyper aware of accuracy and any, you know, trying to break down any black boxes with, you know, claims of analysis ready data. That would be something I would say, kind of like with Dr. McKee, of ask questions and continue to ask questions. If it's analysis ready, make sure you have an understanding of what that means, because it does involve some level of interpretation.
Great, thank you for that. I'm gonna ask this last question and then we'll get to the break, but this is about paying for these kinds of tools and subscriptions, and that many organizations within, I suppose, but mostly outside of this compensatory mitigation community, don't always have the money to do so. So do you see opportunities? What's especially promising with respect to like the accessibility of these kinds of tools in planning, conservation, and wetlands work?
Yeah, that's a great question. Lens specifically was pretty much born out of the need for remote monitoring, and our original bread and butter was in like the NGO nonprofit space. And so our model from the start has been to make this affordable to everyone and have, really transparent pricing on our website that you all can visit. I dropped our website there, but in addition of like creating these partnerships with commercial providers so that you might not be able to fully task an image that might cost $2,500, but instead I can purchase one from, May of this year, and it's 4 cents an acre and might only cost me $10. So creating those opportunities and accessibilities, both within monthly subscriptions and annual subscriptions, for folks. We've worked with nonprofits to help them, write in grants. We have an extensive network with the Land Trust Alliance and working with organizations across the world that have different capacities to pay to hopefully lower the barrier to entry for, remote sensing and this type of work.
Other thoughts, Andrew?
Yeah, we've worked with Esri and also Planet to be able to provide, we have a nonprofit specialty with Esri, and we also have the ability to provide nonprofit pricing discounts with Planet. And also just, raising the awareness that a lot of the data that is widely available in public is usable for analysis. And it's getting a lot better. And so I think it's, again, just raising that awareness of knowing which tool to use, and it's not always higher resolution the better. It can be, I think even getting even a couple images from a drone can be very, very, very helpful. But yeah, we definitely made a point to have nonprofit discounts and make it affordable.
Great. I was going to go to the break, but I do want to get this last question in because, well, I was going to ask about a question about climate, but this one sort of goes to it in a different way. But what is the status of airborne and satellite chemical sensors for like things like greenhouse gas emissions or air pollution from wildfire? And what spatial resolution is now available and may be available in the future? I don't know if you all can answer that, but as we're moving to the break, do you have thoughts?
I know we've looked at, there's some publicly available methane data sets that we've looked at putting in our pipeline for ingesting. It's not quite there yet, but you're right. Like bringing those online for folks that might be concerns for their project are definitely top of mind, in addition to the other publicly available data sets.
Yeah, that's spot on. It's here, and it's only getting better and more accessible. So it's really help strengthening the constant monitoring of Earth.
Awesome. Well, thank you to you both for describing your tools, for showing us these examples. I think we may come back to some of them in the afternoon or in the second part of our webinar when we talk about applying tools to compensatory mitigation. So thank you again. There are a few additional questions in the chat. If you all want to take a look and have any thoughts and you want to answer those, that would be great. In the meantime, we are going to take a break. Let's go 10 minutes to about 2:40. Running a few minutes late, and we'll come back to our second panel on applying tools. So just a break for a few minutes, and we'll see you soon. Thank you again.
Thank you.
It started in 1 minute. Hey, welcome back from break. Yeah, I'm ready to get started with the second half of today's workshop webinar. As I mentioned earlier, the second half is going to focus more on applying these tools and these technologies that we've heard about so far today in a more specific compensatory mitigation context. So our first panel is from the U.S. Army Corps of Engineers. They're going to tell us more about some new things that they're working on at the Corps to help improve implementation of the compensatory mitigation program. We're going to hear from Justin Elkins, the mitigation subject matter expert, Ryan Hendren, mitigation programs team project manager, and David Schaefer, technology program manager, all from the Corps. And the second, while we have our slideshow up, I'm just going to go through the second panel that we have today. In our second panel, we're going to hear from two providers and a land trust working in compensatory mitigation. We're going to first hear from Jeanette Blank, Montana Inland Fee Program Director from Montana Freshwater Partners. She's going to talk about some of the work they're doing on monitoring and adaptive management. Then Bob Siegfried, Senior Project Manager from Resource Environmental Solutions, or RES, is going to talk about a lot of their cool work they're working on using remote sensing and monitoring. And then T. Clarkson, Executive Director from Broadwater Innovations, Land Trust, is going to talk more specifically for a few minutes about long-term management and some of the new things they're thinking about to help improve the implementation of long-term management of compensatory mitigation sites. So first, we're going to turn it over to the Corps. And I'm not sure who's kicking it off.
Hey, Justin, you're still muted.
Thank you, Ryan. Oh, there we go.
Okay.
That should be it. All right, thank you. Over to you, Justin.
Thanks for that, Ryan. All right. I'm Justin Elkins. I work for the U.S. Army Corps of Engineers in regulatory at the Huntington District. And with that, I'll put this statement out. The views, opinions, and findings expressed during the presentations are those of the presenters and should not be construed as an official Department of the Army position, policy, or decision. Okay. My duties at the Huntington District include all facets of compensatory mitigation, from reviewing mitigation projects to assessment methodologies and tool development. It's important to note, regulatory does not create remotely sensed data, but rather uses existing data sets as part of our review process. I do want to recognize the other presenters on the call and others in the industry that continue working towards greater ease of access to this landscape level data and the creative thinking and the evolution being applied to develop closer to the ground applications. I also want to thank ELI for allowing us to participate. And I'm going to start off with highlighting one of our internal tools that allow access and use of best available science related to GIS. Rob Stout and Dave Schaefer are the authors and developers of the National Regulatory Viewer, what you're seeing on your screen. And with support from regulatory headquarters, the Corps National Regulatory Viewer was released in 2021. The NRV provides a centralized portal for all regulatory geospatial information, speedy, user-friendly viewers with straightforward geospatial workflows, and also provides consistent review across the regulatory community of primary source geospatial data sets. So we're at the home page, and we simply just navigate to a particular division. The viewer is going to load up here, and it's going to include tabs from each state within the division. You can see that at the top. It has common widgets as most other viewers, and the layer lists are customized for each individual state. The layers consist of federal, state, and local primary sourced or authoritative data sets. Compensatory mitigation projects, site selection, and baseline information are required as part of the mitigation plan and will include supporting information such as aerial imagery, including historic and recent, and topographic LiDAR. There are other commonly used data sets, but I'm only going to focus on a few at a very high or observation level analysis. I'm going to show a simplistic use, so we'll get some points of reference on the map here. And we'll start with looking at some aerial imagery. So again, we have these information has been organized very well. Again, it's authoritative or primary source data. And so let's start off with turning on. And so what that was a delineation of a mitigation bank site. And we're going to turn on a few different layers to try to visualize what we have access to. So this is 2003 imagery. You can kind of see the lay of the land here. What's shown is a typical setting for a lot of the valley bottoms in West Virginia and elsewhere with some topographic relief. And these were typically used for agricultural purposes in general. So one layer that we do use quite often, and it's from the USGS 3D elevation program suite of that they put out, and that's the hillshade data set. And so you can clearly see that a lot clearer resolution, or things pop out or are more identifiable or observable with this type of information data set that we're able to use. You know, challenges that we have that the aerial photograph imagery is good, right? We can see the barn there, we can see the roads, we can see some stream. But what happens is that we can't see everything. So, you know, you kind of lose the stream, and using this LiDAR overlay, you're able to see where that stream is. And most of that valley bottom area is where streams were pushed over to the toe slope so that these areas could be developed. We don't have a lot of flat land, as you may know, or a similar case in your neck of the woods. So you can clearly see that that's been pushed down or pushed over to the hillside. So now let's look at what we're able to see with some imagery that we have as well. Let me, some different imagery. and we can see in the LiDAR is prior to the date of the aerial imagery that we're looking at. The stream project was constructed and is currently in monitoring, but what we can see is that the reveal here is that the channel now is located within the valley. It's not as confined as you can see from the LiDAR imagery where it's on one side. It actually is able to have overbank flow. There's really only about a 2-foot difference in elevation from, this isn't really an elevated road. It's access for them to come in and do monitoring as they did construction. But you're able to really see, the information again, at a very high level observation so that we can kind of understand where things are as we get the information from proposals and on into monitoring. This doesn't replace on-the-ground data collection. However, it can be informative, whether it's that initial site selection related to resources on the ground or a larger scale using NLC data to determine land use trends and really help hone in and verify, that the sponsors or the applicants are really taking these things into consideration. This was just a very high level, pun intended, of some of the core regulatory capabilities. Assembling maps from different time periods, elevation data, and other pertinent data sets can create a representation of the past and inform mitigation opportunities and constraints. And so with that, I will hand it off to Ryan to narrow down specific application for some remotely sensed data.
Excellent. All right, so we're going to share the screen.
Justin, you may need to stop sharing first. There we go. Well, you're there. Awesome.
I'm out right on top of it. All right, guys. My name is Ryan Hendren. I am with the Jacksonville District Regulatory Division in our mitigation section here. And I'm going to be talking a little bit about one of my mitigation projects that's located here in Tampa Bay. As you can see here, Tampa Bay is one of the larger estuaries that we have. And this little portion that is just off of St. Petersburg. We're using the NRV viewer. And one of the things that we typically look at for this is, so this mitigation bank, they're proposing to restore seagrass within a 32-acre borrow hole, which you can kind of see as this darker area over here. The overall scope of this is about 178 acres. And this is all seagrass meadow with a lighter sandbar right through here on the lower portion. And so typically when I'm doing my review, one of the things I'm looking for is the site selection. And for this project, I'm also looking for historical prevalence of seagrass within the proposed boundary of the site. One of the beautiful things that we have here in the state of Florida, we have a water management district that has been collecting seagrass data since 1988. They fly this area every 2 years. And we have a succession of data points throughout that time period. And it has been able to provide us seagrass habitat data within the St. Joseph Sound, Clearwater Harbor, Tampa Bay, Sarasota Bay, Lemon Bay, and Charlotte Harbor. I've got about 10 years worth of data that's loaded up in the NRV viewer. And what I'll do is I'll load up 2 different portions here. We're going to look at 2016 and 2022. And in particular, what I was looking for when I was viewing the site, to see what it looked like when the project first came into us back in 2016. And as you can see here, the bright green is patchy seagrass, and then the blue is continuous seagrass. And what they mean by that is we're looking at areas that are going to be a little bit more than 50 to 60% coverage throughout the site. As you can see over here, we've got the hole that's turned out as water. Sometimes it would be called bays or estuaries. So for 2016, you can see we've got a good bit of patchy seagrass out here on the sandbars and then some of the shallower areas. But in 2022, those kind of broke down and we started seeing still continuous seagrass throughout here, but we started seeing some of this other submerged seagrass. And typically that can be macroalgae or some areas that are coming back with some other seagrass species. So what we were hoping to find was making sure that this was a stable area over time. And looking at the individual years, we don't have enough time to really go through them all here. But we noticed that this patchy, or the patchy area waxes and wanes over time, but the blue continuous seagrass has maintained throughout the duration of the data set time period that we have. So that gives us a good level of confidence that when this area is mitigated, that it will have a very stable seagrass area that will help the restoration of this area overall. And with that, I will pass it on to David.
Hey, good afternoon. Can everybody hear me?
Yeah, you sound great.
All right, great. I will show my screen. All right. Yeah, good afternoon, everyone. My name is Dave Schaefer. I'm the Technology Program Manager for the South Atlantic Division Regulatory Program. We're composed of 6 states and 5 districts, and we're the largest division by workload. My background is fluviogeomorphology and remote sensing of wetlands, and I was a core regulator for 15 years, and I've been in this position for 3 years. My job now is really to help modernize the Corps' regulatory program with some of these tools that you're seeing. I'm one of the lead developers of the National Regulatory Viewer, which you just saw, and then also one of the technical leads for the Beta E application system called the Regulatory Request System, if you've heard of that. So hopefully you can see my screen. I was asked to talk a little bit about some of the field apps that we've been developing in the National Regulatory Viewer to assist our project managers in evaluating some of these mitigation projects as well as other types of development projects. A lot of the work that I've done with some of the field tools that we've developed are really come out of the Jacksonville district, since they have such large mitigation sites and large mitigation projects, to just help them be able to document sites and then be able to turn that around quickly in our administrative records. So what you're looking at here on my screen is what we call field reports within the National Regulatory Viewer. I'm in the South Atlantic Division Viewer. And what you're seeing is our points. We're still not, we've been traveling in the past. I think we've had this system up about 3 years now. And we're still in the process of visiting all the districts and training them on the use of the system. But you can see it's quite popular. These are photo points. So these are where our regulators have gone out in the field to take photographs for whatever reason to document the site and what they're seeing in the field. There's about 36,000 photos that have been taken in roughly 3 years. Again, as I mentioned before, a lot of this stuff was developed for the Jacksonville district for that to help them document some of these large mitigation sites in Florida. We've got a 3-day training course that we teach our regulators. We use field maps. Everything's built on the Esri, ArcGIS Enterprise Portal platform. So we have a whole class with labs that we go out to the districts, and we teach them how to use these field apps. So this is kind of our photo log feature, which I'm going to show to you. And then we also have the automated data sheets, which I think a lot of folks on this call are probably familiar with our automated data sheets. This is our version, our internal Survey 123 version of the automated data sheets, which we're trying to make available to the public, but we've had some challenges there. So basically what the regulator does is they use field maps to take photos. In this case, this is a large mitigation site in Florida. They come back to the field and open this in the National Regulatory Viewer. They select what points they want to export. I'm not going to actually do this because this is it's a geoprocessing service, so it sends all this data like most tools in ArcGIS Pro. It's just a tool that has been published to the web, to an ArcGIS server, so it can run in these viewers. But basically, they just give a project area. It can be a KML or a shapefile, whatever they have, and they run this service. And in the case of the photo log, there's a couple things you can do here with the photo log. It's going to produce a series of maps for them. So the first one, if they choose to select only certain photos in the site, say they only visited the northern part of the site and the southern part of the site, it's going to create a nice index map for them, showing where the photos were taken. This is the gridded index view. If they go over to each individual grid, they can see the points, and this is all automatically generated from the tool. So they really just throw this in administrative record. In the past, it took them hours to generate products, and a lot of times they weren't as good as this. So each grid shows the photo points and numbers them, and then when you get to the photo log, it's going to provide the photo as well as an overview map of where it's on the site, and then the number and direction of that photo. There's also some information and metadata about when it was taken, what sensor was used in terms of we use government smartphones, primarily iPhones and Androids. So again, this has taken something that took us hours and hours to do. It's just a couple minutes exporting the photos, and we have a nice professional photo log to look at. So that's widely used, and again, it's been deployed nationally. As you can see, it's a very popular product that we have in the National Regulatory Viewer. Another thing we do within the field reports application is we can export inspection points. So our enforcement section down in Jacksonville uses this a lot, and we're training a lot of folks throughout the country to use it. So we have widespread usage. We're just still training people. The product of this, it's the same workflow where they basically select a point and give it a project area, and then they'll run the tool, and the tool will produce. I provided a very simple example here, but we have a Army correspondence memorandum or regulations rather that require us to have very specific formatting on our reports. So it generates a formatted memorandum for the record, an Army memorandum for the record. So it'll give you your map that shows your review area, and that's digitized from, or whatever the project manager digitized, be it a parcel or shapefile or something like that. And it just gives them kind of a framework to fill this out. They can put their name in here. They can any comments. Typically, they're going to dictate those their notes in the field, and then come and clean them up in the administrative record. And any photos are going to be attached at the end. I only have one in this example, but it can be as many photos as you want. The last thing we have is in our field reports application is the automated data sheets. So again, if you're familiar with those, the Corps actually has an internal version of the automated data sheets as well. This is kind of what they look like. Nathan Schultz with the Detroit district's the one that created this particular part of the NRV, and it's really neat because the survey gets fed directly into the National Regulatory Viewer, and I can turn that on. And our project managers, we don't collect a lot of data sheets. We're seeing more of it. Depends on what district you're in. But we've made it pretty simple to be able to come back. Yeah, you can see we still don't collect very much data sheets unless you're familiar with the New Orleans district, who does a lot of delineations. So basically, same workflow where they can select the points and export the data typically into a comma-separated file, and we have a special version of the field data for ADS. So once they've exported that data, it comes in a zip file. Let's see here. And you can select as many data sheets as you like. It comes with an overview map like this. So in this site, they collected 2 data sheets, so it shows it on the map. And then these are the 2 data sheets that get exported. Unfortunately, at this time, because we just haven't had the time to invest in developing it, but you do have to import what's produced in the regulatory viewers into the automated data sheet. There's this little button here, and you just click open, and it will populate the data sheet. And then the project manager can just export this to a PDF and put it in the administrative record. So I don't think I missed anything. Justin, did you have any other things you wanted me to talk about relative to the National Regulatory Viewer? I certainly could talk a lot about it.
Yeah, I think we hit it all, Dave. Just kind of to let folks know, I'll just kind of wrap up, Rebecca, that we are really, Dave and Rob and others, Nathan, a lot of folks, we have a lot of expertise, and we're really trying to consume, as you see, we're trying to consume this data, and then we're also trying to use this, these capabilities to better inform, to help us be more efficient. And with that efficiency, I'm not trying to diminish that. It allows us to take time to review things and have things at our fingertips, and to verify information coming in the door. So it was really great to hear folks from earlier, and I'm sure others after, about how they're using it to help us understand, whether there's success with the compensatory mitigation problem, or with the compensatory mitigation site, or if there's challenges, et cetera. So, but we appreciate your time.
Thank you. Thank you all. That was great. We really appreciate your coming to this webinar to tell us about it. Justin, do you just want to mention, you answered some questions in the Q&A. We had a couple about whether or not this was going to be publicly available. I'm not sure everybody saw that, so maybe you could just talk a little bit about that.
Yeah. So this is an internal, I just kind of hit on thing that we developed. We're able to leverage enterprise-wide, basically civil works software licensing that we're able to use and really create this. So we're not everything that we are consuming is publicly available, unless it has to do with some ESA or 106. So we definitely won't be putting this out as a public. I did put in the chat, the national map is a really good place to start. You can add data, just like you saw me. You can get LiDAR. So for the public, that's a really good starting point. And there's likely other state viewers that are available. I know Ohio and West Virginia offer, you can just go in and do what I did, and all the layers are there. We've just curtailed it to our specific needs with, related to permitting and related to compensatory mitigation. And as well as we've got some non-public information but yeah, so hope.
Great. Thank you so much to you all. There may be more questions coming in, but for now, I'm going to turn it over to Jeanette to give us an example from an in-lieu fee program of their integration of some new technology. So Jeanette.
Great. Thanks, Rebecca.
Thank you.
Can you guys hear me okay?
You sound great.
Okay. Let me share my screen. And then I'll pull my presentation over. And hopefully you see
Looks good.
the screen there.
Perfect.
Okay. Great. Okay. So thanks for having me join the panel. My name is Jeanette Blank, and I'm the program director for the in-lieu fee wetland and stream mitigation program here in Montana. Montana Freshwater Partners, we are a small nonprofit, and we administer and run the in-lieu fee program across our state. Let's see here. I have a strange view on my my screen here. Oh, well, we'll go with it. Okay, so we have about a dozen sites, mitigation sites scattered across the state. And Freshwater Partners, our office is located down here in Livingston in the Upper Yellowstone watershed. And it takes about 2 hours to drive to our closest site and about 6 hours to drive to most of the other sites that we have across the state. So we are a tiny little nonprofit. There's 3 of us that run the entire program and do all of the monitoring for our sites across the state. In Montana, we don't have a lot of credit sales. There's not a ton of wetlands or regulated streams in our state. So therefore, there's not a lot of mitigation credit sales that go on here. So we have to be very mindful and careful, not only with our time, but with our costs. And so this is how remote sensing has really become useful. What I'm going to share with you is not rocket science. It's sort of like how someone who is not a tech genius, such as myself, I'm not a tech genius, can still use remote sensing in a way that's it's really useful and applicable. So we keep it pretty basic. We use aerial imagery, historic imagery, NAPE imagery, the commercial satellite imagery that both Clay and Andrew had talked about, color filters to kind of evaluate vegetation and hydrology changes over time. And then we do have a drone, and we have started using drone imagery, but drones don't always, you know, you drive 6 hours out to a site and it's windy, you can't really use your drone very well. So being able to access this remote data is super helpful and important. We also use LiDAR data to for our conceptual design, streamline our delineation mapping, and in some cases, we can use the topology from LiDAR data to forego having to do on-the-ground topo surveys. Every once in a while, we can make that work. And then we also rely on climate data to sort of inform or kind of put our what we're seeing on site into perspective with what's happened historically and what's happening for that particular season in terms of water use. So I'm just going to give you a couple of examples, and this might be super helpful for those of you who are pretty new to remote sensing, or those of you who are in small organizations that don't have a lot of money to do a lot of on-site monitoring. So this is an example of a pretty, very rural, remote wetland site that we have way up near the Canadian border. It takes about 5.5 hours to drive there one way. And we have been using commercially available aerial imagery to track early season versus late season and year-to-year changes at the site over time. We've also used it to track construction progress and site conditions. Maybe we need to get some major vegetation control done. We've paid somebody to do that, like, 5 hours away, and I can go online to these commercially available images to see if that's actually happened or not. We can check vegetation change over time, community conversion, and surface water inundation extent over time as well. So here's just an example. This site, it's a saline depression wetland site. It changes dramatically over the course of one season. So if I come out there in May, I will probably see that this site is inundated with water and maybe has 5% vegetative cover. I go out there in July, it's a different story. A lot of that surface water is gone, and now maybe I have 60% veg. I go out in August, it could be dry, crispy cracker dry, or it might have vegetation cover at like over 95%. So it's super helpful to use commercial aerial imagery, and Freshwater Partners, we happen to use that lens program that Clay was talking about through Upstream. And I gotta say, for somebody like myself who is not, technology, I've always been very resistant to it, and probably the biggest hurdle to accessing remote sensing data is just the fact that I don't want to spend time digging through all these different sources of commercially available imagery. And when you get a service such as Lens, or there's other services out there like SkyTech, I'm sure, is that you've got it right there. I can just circle the site that I'm interested in, which is my site here, and then it's like, all that imagery comes up for me, and I can compare and contrast. And so this is a great way to sort of fill in the gaps when I only go out there once a year. And then I can show, my IRT is like, hey, I'm really concerned that this site is all just surface water with very little vegetation. I can pull up imagery from later that year to show, you know what, actually by August, the entire site is covered in vegetation. And so this is an example of this mitigation site, an aerial photo that's commercially available that is taken in May, and it has that color IR filter on it so that the green vegetation is popping out red. And we can show, yeah, in May, when I came out to visit the site, it was very minimal vegetation, but we actually had quite a bit of surface water on the site. By August, same site, now we have a whole, you know, we have a lot of vegetative cover. And even in these areas that are white, which is a saline, basically a saline crust of oversaturated ground, we still have signatures of vegetative cover there. So great way of filling in your data when you don't have the budget or time to go out and visit these sites multiple times a year. So another example is where we use imagery, LiDAR data, drought indices, and antecedent precip data to evaluate dynamic wetland sites during periods of extensive drought. So Montana, like a lot of areas in the country, has been kind of enduring this like ongoing drought. We have a prairie pothole site, which looked beautiful last year, but the years leading up to this, it looked horrible because we've been in a drought. And this mitigation site was under severe to extreme drought conditions for 4 out of 5 monitoring years. We were lucky enough to hit it, be out there 1 year during normal conditions. But we were, well, in the year 2022, we were at the end of our monitoring period. We're at year 5. According to our final site plan, we were going to base our final credit generation for the site based on the delineated boundary that we observed in year 5. Year 5 was an extreme drought that had been preceded by 3 years of severe to extreme drought as well. So this photo on the left-hand side is our site in year 2022 in early June. This is when it should be super wet, and it was so dry. It was very sad, and we're just like, gosh, we know this isn't a failure of the site. It's this overall drought that we're in. And to kind of prove that, the photo on the right is a photo of that same site, same location, just 1 year later when we had normal precip. But because we're a tiny little organization, we don't have unlimited spending, we really needed to close out this monitoring period if we could, but provide data to our Army Corps and our IRT to give them an estimate, a reasonable estimate of what we would consider a normal wetland extent for this site. So we went back to the climate data, to drought data and precip data. We paired what we were seeing on site with what the kind of overall drought and precip data was showing for this county and for this site. And then we also paired that to imagery. So here's how we did that is we just pulled up the Palmer Drought Index that's available on the USDA website. And our monitoring period for this site was from 2018 to 2022. And it was in pretty hard times drought-wise for most of that time. And here's that period in 2019 where we actually had a normal water year for that site. So this is going to give us a kind of a county-wide view. But then as far as site data goes, I like using the EPA's antecedent precip data tool. This is a free tool you can download. And what this is going to do is you type in your location of your site, you type in the days that you were on site for your monitoring event, and then that tool is going to pull weather data from all of the local, automatically pulls it in from all the local weather stations, and like shows you this graph, this chart, and everything in orange is showing you that range of normal precip over time for your date range. And then the blue line, if you can see that, is what the actual precip accumulation was for the dates that you were out there. So for this particular chart, I was out there in late May, and leading up to my site visit, I can show that, yeah, it was, you know, the accumulated precip for this year was well below normal, which lines up with the drought conditions that we're seeing here. And then we tie that to the aerial imagery as well. So here's the site. And this is where we layered aerial imagery with the LiDAR data to get that topography. And what we ended up doing as far as adaptive management goes for this site is because we were at our 5-year monitoring, end of our monitoring period, we're trying to define what is a reasonable extent of the wetlands so that we can get, be fair about like what this site has generated in terms of mitigation credits. The black line is what we actually delineated during the final year of monitoring during extreme drought conditions. The outer green line was what we actually anticipated when we first developed the site map or the site plan for this site back in 2011. And that was actually based on a really, really wet year. And so when we compared what we saw at the end of the monitoring period, which was extreme drought, versus what we anticipated, which we didn't realize was based on a very, very wet year, it looked like the site did horrible. But when we go through, we use that weather data, the climate data, and the aerial imagery, coupled with the LiDAR so that we could use those topo breaks in the LiDAR, we were able to estimate what would be a reasonable extent of normal conditions. And that's what that blue line represents. And so this is what we proposed to our IRT, our Army Corps, in terms of like, this is what we're requesting for our final release is credit generation based on this blue line, which we believe is representative of normal or sort of average wetland conditions that we can expect in the future. And fortunately, when we went out there in 2023 just to kind of check on this site, that happened to be a normal year. And so we were able to kind of walk that boundary, and it actually lined up really well with this blue boundary. So that was one way that we were able to use remote sensing to kind of close out a site, estimate a reasonable projection without having to continue to extend our monitoring site indefinitely until we hit a normal year. So that's our approach to it. I have all of the kind of main sources that we like to use for this data. I didn't mention Ag ACIS climate data. That's another tool that you could go in to get your growing season. You could also get accumulated preset graphs and things like that. So I can copy this into the chat if folks have questions about that.
Awesome. Thank you so much, Jeanette. Those are really great examples of on-the-ground use of these tools. And what I really like too is, as we've talked about, that how these remote sensing tools can help when thinking about how climate change is going to affect sites moving forward. And I think that last example is a really good example of that. So I really appreciate that. I'm going to move to Bob for now, and then we'll come back to questions at the end. So please put your questions in the chat, and I'm going to turn it over to Bob. Thanks again, Jeanette. Looks great.
Unmuting helps.
There you go.
So,
Great. Thank you.
Jeanette and some of the other presenters did a great job of talking about the technology and giving examples. I'm going to take opportunity, and is my screen sharing?
Yes, it looks good.
Okay. So as an ecologist, 30 years of experience, a lot of that involved in mitigation and restoration and both the designing and monitoring of that. I'm going to take a little bit of a philosophical approach to the discussion about why should we use remote sensing and what compared to what we're using today. And I think one of let me
Not moving.
yeah, let me get this going there.
There you go.
All right. So for anybody who may not be familiar with how most traditional wetland, I'm going to stay with the wetlands, we do streams and wetlands, the performance standards that you have and how you monitor them are dictated through the mitigation process. For a wetland site, it's, 3 things: vegetation, water, soils, and probably some other parameters. Vegetation monitoring is measured through often, and this is a generalization across many core districts and states. There are variations. So just kind of with that caveat, vegetation data is often collected with 1 meter plots to determine things like percent cover, how much of the ground is actually covered with veg. What kind of species do you have in the herbaceous layer? Are those species wetlands or upland species? Are they invasive species? And then if it's supposed to be a wooded wetland, some sort of stem count. So you can look, and that the diameter or the shape of that may change depending on which core district you're working in. Wetland hydrology, key component for a wetland site, almost always monitored by wetland monitoring wells, and plotting that data over time. And you show success by showing you have a certain number of days of saturation. That varies depending on where you are and what the growing season is how many days of saturation you have to meet that performance standard. Then there's often some maybe requirement to look at the soils. Are you developing hydric features? Ground level photos is a common thing. Take photos in all 4 directions from a same point over the 10-year life of a mitigation bank. Sometimes it's 7 years. So these are the sort of standard ways that we collect data on a wetland mitigation site to show that we have in fact created or improved or enhanced a wetland to generate the mitigation credit. I like to point out, the drawbacks of our traditional mitigation monitoring. It's sort of like the meme on the right-hand side there. A bunch of scientists with their eyes closed, touching a very big thing, an elephant, and coming up with very different answers. And that's sort of the approach, in my opinion, of mitigation monitoring that I learned in college many years ago, and it has not changed that much since the beginning of the wetland mitigation, in the 90s or the late 80s. Looking at plots or point data, let's say, whether it's the veg plot or a ground-based photo or a monitoring well, and then using just that little pieces of point data to kind of tell how is the whole site performing. Unfortunately, if you're only sampling 5% at most, maybe sometimes as less as 1% of a site, you don't get any sort of system-wide understanding of what's going on this site. And that's what we should be monitoring is the ecological system, right? And that approach, I would argue, is not very transparent. If you're only sampling 5%, then you're not sampling 90-some% of the site. And that means, problems are easy to miss or maybe hide. And anyway, anytime you have those potential perceptions, something was missed or hidden, it creates a problem from the industry, creates a problem from the public agencies. And so I would argue that the current approach of plot-based type data, and that goes for streams and wetlands in many ways, has a problem with transparency. And it's really not very efficient. It takes a lot of labor to go out and collect data from hundreds of wells, hundreds of veg plots sometimes. You have all this point data, and it doesn't come together well to tell the story or the picture of how this ecosystem is developing and maturing, and whether it's moving in the right direction, positive and negative trends. And the data collection, if a particular portion of a wetland is highly successful in the first couple of years, in many times you collect that same information on through the life of the program. There are cases where you're allowed to terminate that and not collect the same repetitive data sowing success. But I would argue we should kind of change how we think about the allocation of resources and labor so that we're collecting data more intensely where there are problems So let's think about a different way of monitoring mitigation, and that is three parameters, right? It needs to be holistic, big picture, whole site, understand the system, that it's transparent, easy for everybody to interpret, that there's nothing to hide, and you're looking at trends. Is it moving in the right direction? Is it moving in the wrong direction? So you can take action if it's going in the wrong direction. And let's collect data, as I was saying, on the problem area, so we understand, go in, correct those problem areas. And I think if we kind of focus and build a monitoring approach this way, it takes less time for the reviewer to review, because it would be easy to put the whole picture together, understand how the system is working. So some of the new, I put new in parentheses, because drone information, aerial imagery is actually not new. It's been around for a long time. It is getting better, better, and better. Maybe that's the new part. More cost effective. Pretty much every engineering firm, survey firm, we all have drones now. So it's readily available now to go acquire aerial imagery through third-party providers like we heard today, or yourself. And that imagery is way more adaptable to mitigation sites as they become larger and larger and larger over time. And gives you that big, holistic, transparent image of what a site is, how a site is performing. I think there's several other technologies out there, again, not actually new, but new as they're applied to mitigation in general, would be real-time data flowing in from the site to your desktop. And I'll touch on the capability of doing that now with well monitoring. But it could be temperature, it could be other ecological performance standards. And then last but not least is the 2008 mitigation rule, which was the last time we tried modernizing mitigation, the last effort that for modernizing, really stressed ecological performance. And you know, if you look at most mitigation banking instruments, there it's tied to, again, how we delineate sites, soils, hydrology, and plants. And relatively few requirements out there to do habitat assessments, do ecological sampling, or even you know, something newer like eDNA sampling. I think all these methods have the ability to meet these other principles: holistic, transparent, and more efficient. And they really kind of line up. That vegetation monitoring lines right up with aerial imagery. Wetland hydrology now is available in that real-time method, and I'll show you some of that. But I thought this was a really interesting, you know, a lot of mitigation banking instruments have a percent cover, and that's usually determined on a 1 meter square plot. But I truly believe initially, you know, from working mitigation sites years ago, the real concern was you build a wetland site, it's a freshly constructed bare ground post-construction site, or in this case, we took a dam out of for a farm pond to put a stream and a wetland back in. So you have an immediate area, potentially erosive area, and you want to know how fast does that veg up and become stabilized, so you don't generate a water quality problem from your mitigation site. Now, we could have gone out and done plots on this. August, we dropped the dam, drained out, was torn down and drained out. By October, the site is almost fully vegetated. As you can see, an aerial photo answers that question beautifully. And I could give this to, you know, a middle schooler, and he could describe the difference between the two and where any problems areas are. It's easy for everybody to interpret, even the public. You may have concerns about these kinds of dam removal projects. Notice the photo is exact same location in the air, positionally and elevation wise. So you can program that acquire that photography repeatedly, so it makes that comparison very easy. Even on the ground photos often are poorly placed year to year. And we can solve that with drone problems and provide information that instead of half a dozen plots or a dozen plots, I think sampling like this is much more efficient and effective. We've heard from a lot of folks today about remote sensing, how it's used. This is a titled site, a couple thousand acre site, one of our sites. I think one of the things that we feel that when we go to aerial photography, aerial imagery for vegetation classification is that collection of the classification data. Most folks involved in mitigation and reviewing mitigation monitoring points really want to see what other species involved, are they wetland, upland, and so that classification data that you need to do for, or you should do for proper, very site specific veg classification becomes that listing of the species, allowing you to properly classify that image. And again, multi, 1,000+ acre site, we can fly this thing the same way every year and get the same, run the same sort of analysis and be able to really quantify acres of wetlands over time in a much more quantitative manner than trying to do the same thing with ground recon with human labor. This is the same site with where the aerial imagery was used to detect invasive species, European based grasses in a pasture and other species out there. One of the things, if you've ever done field work, particularly in areas with maybe some really nasty invasives, one year you may walk through it one way, the next year a different crew goes out, they're going to walk the site a different way, they're going to map it somewhat differently. And so year-to-year comparisons become sort of difficult to do, and there's a lot of human bias in that, where with a drone and imagery processing, you kind of eliminate that field bias, generated bias, the personnel bias that can come with field work. And sort of reflecting what Jeanette mentioned was, let's reallocate labor, which is expensive and harder to find, quite literally, from driving for miles, for hours, and walking a site for hours or days. And let's reallocate that effort into away from the data collection phase and more into the understanding what the data is telling us, so that we could better manage the site. And in this case, managing the invasive species and planning out the control program, following up the control program to make sure that the next year's imagery is showing improvements. So it's the way of reallocating human resources, financial resources into the harder part of mitigation monitoring, which is the analysis and then the corrective actions. Hydrology monitoring we haven't touched on, but it is equally as important in wetland mitigation as vegetation, which could be looked at with remote imagery analysis. If you're not aware, traditional wetland mitigation, well in the ground, you may have one or more per acre across the site. We have sites in Georgia with as many as 250 monitoring wells. So that's a lot of data out there being collected. And it is typically a small data logger that goes down into the well, and it has to be manually downloaded in the field several times a year, as many as 4 times a year. So again, somebody, usually at least 2 people or larger crew, are going out, spending a day or multiple days manually downloading data and bringing it back to the office to be post-processed. Obviously, because you're not getting that, seeing what's going on in your site. You could have a flood, you could have beaver, you could have a lot of things happen on your site, and you're blind to it until after you get that data and bring it into the office. So that's not an ideal way to be proactively managing a mitigation site. I've worked with Onset for the last year, helping them bring to production a real-time water level data management logging system that will collect the data in the field and deliver it to your desktop. Excuse me. This method really helps reduce a lot of human error. You know, somebody forgets to turn the logger on, the barrel logger data is lost. Again, it reallocates labor from collecting the data to actually analyzing the data. You can focus more of your time on learning what the well data is telling you than trying to go out and collect it and bring it back. And it tells you when you have a flood or a beaver moves in and builds a beaver dam, you can immediately react and send people out to assess the situation or address the damage instead of waiting till it's months later and you go out for a manual download and find something wrong. So the challenges to these new monitoring techniques is building trust in the technologies. And I think it's really important for folks to realize all these technologies have been around, but we have to take that technology and use it to modify our current performance standards and monitoring methods. We have to then incorporate that into the mitigation banking instruments. These instruments are often templates in districts. And as a banker, I know if I want to change substantially a mitigation banking instrument, the approval process will probably take longer than normal. Time is money. And so unfortunately, I think sometimes it's more efficient just to say, we'll just keep doing what we've been doing for the last few decades in mitigation monitoring, instead of taking the extra time to move it forward into using new techniques. I'm fortunate I work in Virginia and we have some pretty progressive IRT members that really helped and embraced some of this. Very, very fortunate that way. I think one of the challenges is data delivery. We're going to end up with a lot more aerial imagery, real-time data. How do we share that with the Corps? How do we move away from reams and reams of data in a PDF report? I was actually really surprised to see how sophisticated the Corps' their viewer is, and I'm sure there's a way of marrying the data we collect through aerials, through online real-time hydrology, and be able to feed that into their system in some way. But I see this is one of the things that we'll have to address together, agencies and bankers, as we move forward. And again, just kind of hitting all these ideas, holistic, transparent, and efficient. Let's see if we can move our mitigation monitoring, out of the 1900s and into the 2000s. That's what I got, and thank you all for your time.
Awesome. Thank you so much, Bob. I'm just checking to see if folks from the Corps are on the line. So it looks like, just wondering if you had any reaction to or had been thinking about how the regulatory viewer could incorporate some of these data. Is that like a possibility? Are there ways to do that? Are you thinking about that?
We would, I think it would be a great idea. I would love to see a national level conversation between the industry and the Corps so that we know how to package the products in a way that they can just bring right in. I know the Corps has certain security requirements for data that they accept. And so we would have to be, work through that. We currently use storyboards. I think a couple of presenters had storyboards as a way to integrate all kinds of different data, tabular, visual, time series data that allows you almost do a virtual walkthrough of a mitigation site with all the monitoring data there that if you want to, you can dig down in. But if you don't need to dig down in, you don't have to be burdened with it. And I think trying to figure out how to get get all that valuable information across, but then allow reviewers within the agencies, only to have to see and digest the most important part of that data, but with the flexibility of drilling down if they feel they need to. It's an important conversation to have in the future.
For sure. And Justin, I don't know if you unmuted to say something. Maybe not. But we'll come back to you, Justin, if you have something. But I do want to move on to our last quick presentation, because I think long-term management is really important. I think it's going to become more and more important as more sites move into that phase of mitigation. And so I was really excited to invite T to this presentation just to talk more specifically about that part and some things that they're thinking about. So over to you.
Great. Thank you very much. I believe everything's sharing all right. Appreciate you having me again, T. Clarkson. I'm the Executive Director of Broadwater Innovations. We're based here in Richmond, Virginia, right down the road from Bob there. Wanted to talk a little bit about who we are, what we do. I'll keep it pretty quick, but appreciate, again, you having us. We are a land trust, one of the few land trusts, I believe, in the country where our focus is to serve as an easement holder, long-term steward on mitigation banks. We're currently, and again, easement holder, long-term stewards. We're developing a lot of long-term management plans, particularly now on newer banks. And then we also manage the endowments. So marrying that with the long-term expectations is an important part of what we do. We became very popular when we started this pursuit, seemingly because there's not as many people focused on doing it. So we started out pretty small. Quickly, over the last 4 or 5 years, we are currently holding easements on almost 4,000 acres in 9 states, and then serving as long-term steward on a little over 5,000 acres. That those count together. And our focused, obviously, we're hitting pretty broad geographic regions. So a lot of the monitoring and remote monitoring is going to be important to marry up with our boots on the ground. And a lot of what I've seen so far is kind of the things, I think it's important to note the things that we are thinking about and incorporating. I'm showing you now just some still shots of our landscape software, which is the software we use for our monitoring, both in the field and remotely as well. It marries up with Lens and it's integrated there, so it helps us with our reports. This is pretty similar to the National Regulatory Viewer, I think, in that we can get out, we're on site, we're taking the same photos year in, year out from the exact same spot and really able to determine changes, make notes from year to year in those specific spots, and then upload all of these reports to a PDF version and then download them in Rivets or wherever folks would like us to put them. Again, Lens marries and integrates with our landscape software, so we can utilize that satellite imagery and a lot of the tools that Clay talked about earlier into our monitoring as well. And how is it helping us? It's helping us, again, we can, with funding available for particularly some of the older banks, it's difficult to get out there as much as we would like. So we're able to do some of the monitoring remotely. If a landowner calls us and there's been issues with beavers or things, violations in terms of the easement, we can take a look at some of that using the satellite imagery before we go out, and it works hand in hand with what we're already doing. The same with storms and things of that nature. If there's major events on any of the sites where we're the long-term steward, we're able to look back at previous imagery, look at current imagery, and determine what's happened before we get out there, and also then use it in additional reporting. What do I expect in the, how, again, easement violations, that's big for us. So it helps us if we do have an issue with an easement violation. A lot of times we can use some of this monitoring technology to sort of show what's happened and make it clear when we see a violation or when we anticipate a violation, perhaps before an actual boots on the ground visit. What do I expect in the future? More great things to come, really, and incorporating this more into what we do. The challenges for us, again, funding will be a challenge. Incorporating this stuff into long-term management plans and a big issue for another day, is we're determining kind of what we're going to do in 5, 6, 7, 10 years when the banks close, and trying to determine then now how much funding we'll need when we take over. So it's hard to marry the funding with the expectations in the future and the timing. But that I think the biggest thing takeaway for me is to know that as a long-term steward looking at thousands of acres, this is something that we're paying very close attention to, and that we do anticipate only using more and more as we're monitoring.
Thank you so much. Oh, really big questions, I think. And the money one maybe being one of the biggest as we move forward. So I really appreciate that. Thank you all for hanging on. That's the end of the presentations. And, we have a few minutes for questions if anybody has questions. I know I've seen a lot in the Q&A about the links and resources that have been provided. And apologies for the chat not being copyable, but we do have some of those links in the Q&A, which should be accessible. We will also post all of them to our event page. And as soon as we can get them up there, we'll try to post the links to the resources. The presentations will be there, as well as the recording of this webinar. So that should be a kind of a one place where you can go to find all the information. So hopefully that will be helpful. And some of those are already in the Q&A that you can take a look at. Justin, did you want to add anything on the tool and ability to integrate any other information?
I didn't really have anything.
Oh, yeah,
I really
okay.
appreciate Bob kind of laying that out. We are always receptive to how things can be done. We recognize costs as well as we're trying to execute our program. So it was really great for us to hear some of these innovations, whether it was from Jeanette, from Bob, of how things can be used that really just gives us credible data that we can go ahead and make decisions on. So I appreciate that.
Yeah. I had one question sort of building on that about like how, since we have, multiple locations covered, what are your conversations with your IRTs like? Are you hitting specific challenges? Are they open to using these technologies in your, as you're working through your challenges with your projects, or what kind of resources, or what are your needs now that are going to help you get past those?
Well, as I mentioned, I'm really lucky in Virginia. We, excuse me, I keep choking on something. Our agencies have been really flexible. It's not always the case in other regions, maybe that have we've been doing mitigation here through banks for a long, long time. So they have lots of experience. I think in some districts, they have less experience. And so they may be a little warier of trying new technologies, especially if it makes it harder to know whether somebody's successful, yes or no answers to performance standards. I think that's a big thing. I think when going to aerial imagery and other things, we're going to have to think kind of hard about that, because we don't want to make it harder for the IRT to know when something is not going right. And they need to call a timeout and do corrective action. I think I'll stop talking now.
Jeanette, any thoughts? Oh, we can't hear you right now. I think you're muted somehow.
There we go.
There we go.
I think why our IRT has been receptive is because we're only using the type of remote sensing data that we can explain really well. And so I think that's a key part, is to not use something that's so over our heads that we can explain it very well, but then also our IRTs as well. So just being very practical about it. I think our IRT is receptive to it because it's practical, and they can see that it is a way that we can provide more information than we would be able to otherwise for our site. So they've been they've been very receptive to that. I don't know if we were to just make leaps forward and say, oh, rather than going out on site to do this monitoring or to show that we're not putting in the effort that we do, I think that's where we might get some pushback. But as long as we're using it as a practical tool, they seem very receptive to that.
And this sort of goes to a comment we had in the Q&A about asking if you've ever sort of come up against this. This is how we do things here. This is, why should we change things that we've been, doing for a long time, and that seemed to be working. And they were wondering if that's ever come up, and how did you work through that?
That's why I kind of stressed, like with remote sensing, but also with the real-time hydrology data. It's more holistic, transparent, and efficient, right? We can all spend less time either collecting the data on the banker side, or going through reams and reams and reams of digital, PDF paperwork as a reviewer, and really focus on what, how is the site doing, and in which direction is it going, by looking at aerial photography and be able to see the whole site and not just, a handful of plots. So I think, I think nobody, would argue with holistic, transparent, and efficient. It's just how do you present that to an IRT and compare it against what's being done traditionally versus where we could go with modern.
Yeah. And as mentioned in the last comment we just got, there's a lot of turnover at, the agencies, and that, you may have to, as you mentioned, Jeanette, like explain these things you can explain well many times over and over. Is that something? Do you have suggestions or something you're?
I think, and this was talked about real early on, is just being really thoughtful on how you're pairing your remote sensing data with the question that you're trying to ask or show. And so one of the things that we have talked about, like kind of the I guess the old school view, is that these mitigation sites, you restore them, and then the perception that they should be static over time, and then kind of introducing that concept of like they're super variable. And then especially now, as we're getting more and more climate variability happening, we need to start like being able to capture that and understand that. And so I think that's where that that was a big discussion that we had been having with our IRT early on, was like, this stream is going to change. That's how a functioning stream is, or this wetland boundary, because, maybe, I think a lot of folks weren't very familiar with prairie wetlands and how dynamic they are, as opposed to very consistent groundwater fed wetlands. And so I think having those discussions, and you kind of know, like, okay, this is an area that we constantly have to go back to within discussions, is temporal and spatial variability, and then being able to use remote sensing to kind of show that. And that's when that light bulb kind of hits, and everybody gets a lot more comfortable with it, instead of just trying to push this more this concept that you can't show qualitatively or quantitatively, I guess quantitatively. So but I do think that is one thing, is the quantitative versus qualitative. Like remote sensing can be awesome in terms of qualitative, but a lot of times our IRT wants quantitative data. They want to see a number. And so that's always the tricky part. And so being able to use some of the analytics that go along with remote sensing, which is not something I'm great at, but it can be useful, I think, with the right kind of person. Maybe one of my millennial coworkers can work on that, but this one just does the qualitative.
Right. And I think all that is magnified in long-term management, right? These are dynamic ecosystems and if we're managing for a long time, right, like we have to be thinking about that when we're developing the plan.
Right, and that's something, taking a lot of the technology into account has not really been part of the long-term management plan process. But a lot of the banks that are, are just now closing, that they're not necessarily funded correctly. Maybe they have enough funding sometimes, but so we're kind of forced to start where we, meet that bank where it is, both from a funding and an expectation standpoint, where now, as we have more of these tools, then we can look to the IRT, and they're all different, you know, in terms of what do they want from a long-term steward. And that dictates
Yeah.
the plan, it dictates the technology, and it dictates the amount of the endowment that's going to be necessary for us to do that work in perpetuity. So.
You know, a bank has a life of about 7 to 10 years. So we negotiate that now. So if we choose to stick with the 1900 era way of sampling veg or whatever, then we've locked that into the 30s, right? And then T picks it up and has to carry forward that same technology often now into the 2040s, right? And so every time we make a decision not to modernize our performance standards and monitoring protocols, we're locking in that process for 10 plus, who knows how many decades into the future. And so it's time to start trying some new things so that we can take advantage of the technology tools that are out there and put our good, you know, super well educated, brilliant people at work, you know, analyzing data and, you know, coming up with solutions and not driving for hours and walking for days, collecting data necessarily, you know.
Well,
You
I
have to
could
do that, but you know, there's efficient ways of doing that.
Yeah, and I could not have wrapped this webinar up better than what you just said. So for those of you hanging on, I want to thank you all for your presentations. It was a really fabulous set of presentations. I learned a lot, judging from the comments in the chat and the Q&A. I think the participants learned a lot. So thank you again to all of you. We do have a final poll, so if anyone would, you know, remain on for a minute just to indulge us, just so that we can know, like, how did our webinar do? Did you learn something? What else do you need? And that helps us make these resources that we provide at ELI even better as we move forward. So if anyone, for those of you who can hang on, I'm going to launch that poll, I think, and go back to my polls. And for anyone that wants to answer, it's 4 questions. They're sort of a longer answer. I'm going to launch it now. We just are curious, you know, what do you need to make the use of remote sensing or other technologies more useful in your work? Again, you know, what barriers or challenges are you seeing? What do you want to learn more about? And here's another place to put some resources to share. If you have additional resources that weren't mentioned, or you want to grab a link and put it in that question, we'd be really thankful, and we can send those out to all the participants. So we'll give you a minute for anyone who wants to throw some information in here. It's really useful, again, for us to provide more useful information in the future for these kinds of webinars. So we'll give a minute or two if, you know, anyone wants to put some information in there. But again, thank you all for joining us. We really appreciate it. We had almost everyone hang on for the whole 3 hours. And I think that's a testament to what great presentations we had and the information we were able to provide. And again, thank you to EPA for the funding for this project. Appreciate it.
Mm-hmm.
Thank you for organizing and hosting.
Putting it together, we appreciate it. Thank you.
Of course. Just open for a minute. And we will, for those of you putting information, we'll summarize all this, the information we got from all the polls, and we're creating documents for each of our webinars that will be summaries, and those will go to our webpage as well. So you'll be able to find out what folks added to the link and to the poll here, and maybe that will be useful for you as well. So all of that information will go in. Thank you. All righty.
Bye. Thank you.
So much. Thanks again to all of you who answered the poll. We appreciate it. we'll leave it open as the folks drop off so that if you still are writing, anything you can provide will be really useful. I'm gonna wrap up in about 30 seconds. For anyone still on, appreciate you filling out the poll. Okay, well, thank you all. Thank you all for joining us today. We really appreciate it. Thanks again.